Thanks for watching this clip from my new podcast, In Search of Soil. For more great clips and full episodes, check out the links in the description below. There's something I've heard always on, the more regen ag side, the permaculture side of, weeds are soil indicators. They're going to tell you what's going on in your soil, and they're there for a function. And if you continue that theory out over time, once that issue within that soil is repaired by the weed, which is there to repair, then the soil gets to a point where weeds are no longer needed because there isn't a function in the soil that needs to be repaired. When I explain that, or if you hear that, what are your thoughts on that?
Well, I am a weed scientist. I'm actually elected fellow of the Weed Science Society of America.
All right.
And when I was in graduate school, Bob Zimdahl was my advisor at Colorado State when I was working on my PhD. And I wrote a term paper called In Defense of Weeds, which addressed some of this. I'm a systems ecologist, or at least I like to think of myself as a systems ecologist. I got an undergraduate degree in biology from Lewis and Clark College in Portland, Oregon, and we just did a lot of ecological measurements. So I'm, I agree with the majority of what you just said. Weeds are an indicator. Now, there's no doubt weeds compete for nutrients, water, and a whole variety of things. Harold Coble at North Carolina State University and many other people back in the 70s and 80s did a lot of work that if you get a certain weed population density in the presence of the crop, you got a problem. But I kind of look at weeds sometimes as cover crops, right? I mentioned Gary Zimmer before. Gary taught me no brown soil ever. And I'm sure people that you've talked to have talked about this as well. Bare soil is a travesty because in essence, whether it's a cover crop or better, a mixture of cover crops, weeds could be the same thing. Those plants are capturing CO2 from the atmosphere, photosynthesizing it. And any normal plant will exude anywhere from about 20 to 40% of its photosynthate out through its roots to feed the microbes below it. So if there aren't any plants in the soil at any particular point in time, you're not feeding those microbes, and they're not going to be there, at least at the population densities. They're going to go dormant or they're going to go away. And so I think weeds are an indicator species. I did my PhD thesis on weed seed ecology. There literally are billions of weed seeds that are present in any acre of soil, and they can survive for 100, 150 years. There's a Dr. Beals, seed experiment at Ohio State. I remember from the 1980s that he had started 100 years before, and you were still getting seeds that were viable after 100 years. And that's a whole nother, amazing conversation to have, is how can that be? Because they actually are respiring. But weeds come up as that they are pioneer organisms. In other words, if you have bare soil, what's the first thing you generally see? A bunch of weeds sprout up. Weed seeds are normally dormant, but when they're hit with direct sunlight, that's red light, that'll break their dormancy. When other species begin to grow as well, more of the secondary species, light gets filtered through that canopy and it becomes a far red source, and that's generally inhibitory to weeds to grow. So there's ecological principles, but I think if we want to be kind of anthropomorphic about it, I agree. I think weeds are telling you something. Number one, nature abhors a vacuum, and if you have bare soil, something's going to grow there. And that gets things started in terms of, kickstarting the biology of that soil, especially the microbial population, and kind of setting the stage for nutrient recycling, organic matter, a whole variety of things that ultimately are going to be beneficial to whatever secondary organisms coming in, whether it's a natural, forest situation, and you eventually get, a canopy and more of a mature forest, for example, after a couple hundred years, or you come in there and you plant corn or soybeans or alfalfa or whatever it happens to be, and are trying to establish that as your kind of dominant crop. But I think weeds and cover crops are probably closely related in terms of what they do. A cover crop is a little bit more manageable in terms of seeding density and the types of things we know it'll contribute to the soil. But yeah, I think you can learn a lot from watching weeds and looking at population density of weeds in your soil. I think ultimately when you get your crop established, you want to be very careful about letting them grow because they will steal water and nutrients from the crop and cause some issues.
In terms of stealing water and nutrients from the crop, is that offset at all by having potentially another biological layer within the soil? So let's say you have a cornfield. That corn's growing tall, it's up in the air, it has a certain root profile it's putting out. And then let's say you have purslane growing in the soil. It's flat on the soil, it's covering areas of the soil the corn couldn't. It's probably has a different root profile. They could be competing, but is there also some offset of that competition to a net positive given the purse lane there? And maybe that's doing things that are helping. So it's not just a total, let's say, 10 minus 5. It might be 10 minus 5 plus 2.
That's a really good analogy. You know, it's interesting you would mention purslane. I don't know if you've ever had purslane salad, but purslane is very good weed to eat. And, you know, the definition of a weed, by the way, is a plant out of place. And so, in your situation, can you really call purslane a weed in that particular situation? Is it out of place? It's potentially contributing something. And I would agree with you. I mean, I've done a lot of work in India. And if you go to an Indian sugarcane field, for example, or corn or soybeans, you'll see them growing corn or alfalfa or soybeans or turmeric or all kinds of things in the rows before the canopy closes on the sugarcane. And you know, they're getting a yield from it. But I think what we'll find in time that those crops are contributing, you know, complex carbohydrates to the soil that actually benefits the sugarcane. Because I think, you know, what we're learning is that any plant actually provides that useful function. It'll draw CO2 out of the atmosphere, you know, convert it to a complex carbohydrate, uh, you know, exude some of those carbohydrates and other nutrient-rich materials from their roots to feed the microbes. The microbes, in turn, will capture that, consume it as a food, and if they have certain functionalities like nutrient recycling, you know, liberating manganese, iron, magnesium, phosphates from the soil and putting them in a form the plant can use, or that their biomass, you know, accumulates and gets deposited as organic matter, will help hold water. Yeah, you could make a case that you know that purslane, to use your specific example, actually was potentially adding to that. Because if the purslane is underneath a canopy of corn, for example, I wouldn't worry about trying to control it because it's not going to be very effective because it's again, you know, now getting that far red light and it's going to be limited in terms of what it might be able to do anyway.
Hi, everybody. Thanks for watching. Subscribe here to get the latest from the show. Also, be sure to check out some of the great clips and watch the full interviews right here on In Search of Soil.